Okay. Right, now, next lesson. So if you were to look at the top of page 89 and 91, notice a slight difference in the titles. The first one is called Integration, Indefinite Integrals, whereas the next one is called Integration Definite. Alright. So what is the difference between indefinite and definite integrals? So the first thing, indefinite integral is more general. It just means the antiderivative. Whereas you'll notice with these ones, the definite integrals, notice how each question has two numbers on it. So it's almost the same. There's just a small change you have to make. Let me show you what it is. Kind of like this, but not quite. But you're right. With these ones, there's not a C. So, small f is the function, and big F is the antiderivative. So this actually just equals big FB minus big FA. So, as an example, if I said x squared 2 to 5, what you do is you calculate the antiderivative, so that would be x cubed over 3. And then this is where the key difference is, okay? You do not need a plus c anymore. I mean, you could still write it, but it will cancel, so you don't need to write it down. And then what you do is you put in x equals 2 and x equals 5 into your answer. So you first put in the top one, you get 5 cubed over 3, and then you put in the bottom one, so that's 2 cubed over 3. Is that right? Is that right? Yeah? And then the 3 goes into this, so 3 goes into 11, 3 times 30, 20, 39? Is that right? Guys, you're the ones with calculators in front of you. 39 it is? Right. Let me zoom it. So, what's different between this and the last lesson? Well, not much. Yeah. First difference is that you're given these numbers here. Now, for vocabulary, these numbers are called limits. This is called the lower limit. This is called the upper limit. No, I need full attention, please. Yes. This is called the lower limit, and this is called the upper limit. Okay? After you calculate the antiderivative, what you do next is you first put in the upper limit, then you put in the lower limit, and you minus. Always minus, always upper first, always lower second. There's no choice there. Upper minus lower. No choice. And it's usual, it doesn't have to be, but it's usual that the bigger number goes on the top. So if it was the wrong way around, it's not wrong, it just is not usual. It's not normally written like that, although there's nothing wrong with it. So you might say, well, what is the use of this, okay? Because we know the antiderivative is the reverse of the derivative. And the derivative we've seen can help us find maximum, minimum, and turning points. Well, it turns out, when we see in the next lesson tomorrow, that this antiderivative, does anybody know actually? So if we think derivative represents what on the graph? No, derivative. You're giving me the answer to this. Yeah, the shape is for the second derivative, and then the first derivative will be the slope of the tangent. In fact, it turns out the antiderivative here represents the area on the graph. The area. Now, that is something we'll see in the next lesson. But just for today, we're just practicing putting in these limits. So I'll do another example now. So for example now, so this one here, which rule do you need for 1 over x? The last rule, yeah. Where a is 1 and b is 0, because there's no plus number at the end, and a is 1. So in fact, 1 over x very quickly just becomes log x, where x is 2 and x is 9. A lot of people don't even bother to write the x equals, they just write it like this, 2, 9. Okay? And in fact, some people, just to show you, might even write it like this, with just one line, make it even quicker. Anyways, the point is it's all the same. So we put the 9 in first, and then minus the 2 in second. Now, when you have log and minus a log, you have a rule for logs that lets you simplify it. What is it? Divide. So in fact, you can just write this as log 9 over 2. Sometimes in the exam they want a decimal, and sometimes they don't. What are you talking about, Amber? Log 9 minus log 2 is log 9 over 2. I know. I'm using the second rule for logs. Log x minus log y is log x over y. Where were you on Friday as well? I have to tell you something. I've done this for 6 years, and nobody has ever given me the answer. When I asked them, where were you last week? I don't know. And you know what's funny? I believe you. I do. And let me tell you, Amber, that's bad. That's a problem, okay? Okay, so another example now. So let's say we have this one now. 0, 1, x squared plus 1. So like before, antiderivative. So that becomes x cubed over 3 plus x. So you put in the 1 first and you put in the 0 second. So 1 goes in first, minus, and then 0 goes in second. So we get this. Well, see, this is the thing. If I did use plus c, where would it go? It'd go, everybody look up, because that's a fair enough question. If I wrote plus c here, yes, I would have to write it here and here. They always cancel. Always. So it's just a matter of saving time. It doesn't affect the answer. It's because it's always minus, so it always cancels. Okay, so in the exam, they sometimes want the answer as a fraction, and then sometimes they ask it as a decimal. Okay? You can check your answer on your calculator, but I promise you, I will know if you just use the calculator to get the answer, because there won't be any workings and you won't get any marks. So you can check that you got the right answer on the calculator, and you can see that the button is on the top left. See it on the top left? You see it? Yeah. So if you press that, it should open up the integration symbol. Yes? Now, you can type in the lower limit, 0, and then up to 1. And then I'll just keep moving around until I get the center here. So I've typed in the 0 and the 1 as the lower and the upper. Now, how do you type in the x? Alpha button first, up the top, alpha. And then you can see there's a red x above the number 9. So x squared plus 1. Yes? Wow. Doesn't matter. So if this here was negative, so like minus 1, then you get minus 1. It'll always cancel. Positive, negative, whatever. Don't worry. It'll cancel all. Are you sure? I'm having some weird mode. Zero. I've given a couple 0 before, yeah? Weird. So I'll say it again. No, don't do this. So I'll say it. If you just write the answer, you won't get any marks. Okay? So like for example, there was a student here in the mid-semester who just used their calculator to solve the quadratic. And I didn't give them any marks for that. So you can't just use your calculator to solve this one. But I do recommend that you check. So if you type this in, and you see it's 4 over 3, and you've got 4 over 3, well then you know you've got full marks for that question. No problem. And this question, the number of marks is between 3 and 5 marks, okay? So like this, probably 3-mark question. And then if they ask you to give it as a decimal, so if they said here, what would this be? Yeah, what would this answer be to one significant figure? To one significant figure. Yep.
1.3.
All wrong. It's not 1.3. It's 1. Because you're confusing now significant figures and decimals, you see? So then if I said, give me this answer to one significant figure, then the question would be a 4-mark question now. Okay? And then if they had something in here like plus EX, so something different, then it becomes a 5-mark question. So it goes between 3 and 5 marks. Alright? I'll do one now with an E in it. Yeah? So for example, let me give you one that'd be a 5-mark question in the exam. So something like this. So this one here is EX plus square root X, and I want the answer to 3 decimal places. So the reason this would be 5 marks is because you need 2 rules, you need to convert one of them, and you need to round your answer off. So firstly, before I even start, I have to write this as x power a half. Before I even begin. Now I can use my rule. So what does EX become in the antiderivative? EX. And then this one here, the x power a half, not a half, sorry, 3 over 2.
Over 3 over 2.
There we go. Okay, now we put in the 1 and the 2. So putting in the 2 first, we get E squared plus 2 power 3 over 2 over 3 over 2 minus E1 minus 1 over 3 over 2. Because I know that the 1 power will just be 1. So this will be E squared. Now, what's You can write this as plus 2/3 times, now when you have power a half, what's that? Square root. And then 2 cubed. Well, actually, before I even change it, I'll leave it as 3/2 because I can add these together since this one here is like 1. Yep. And then this one here, that'd be minus e minus 2/3. Alright, so this one now would be e squared plus 2. What power would I have here? What power would this be? 5/2, yeah. What? The first rule of powers. The powers add. Yep. E minus 2/3. Okay, now we can clean this up a bit more. So we'd get e squared minus e plus 2 power 5 square root over 3 plus 2/3. Now we can type it in as 2 decimal places. So what do we get there? You got an answer? Oh. E squared minus E1 plus fraction square root 2 power 5/3 plus 2/3. So as 2 decimal places, I got 7.22. Yeah? Now what I'm going to do is check my answer. That is 7.22. So integrate, what was it, from 1 to 2, wasn't it? And then it's e power of x plus square root of x. No, I must have done something wrong because I got out 5.88. So it's a sign mistake?
Yeah, the E, the second bracket, the center.
Oh.
Plus,
Yeah, what the heck is that? That's a plus, isn't it? So let me just fix that in red. Plus, plus, plus. So now here is minus then. Okay. So I should get 5.89. So let me check that again. E squared minus E1 plus fraction square root 2 power 5/3 minus 2/3. Now, yeah, 5.89. So you see, it's very useful to use your calculator because if this was me in an exam situation, I know I should go back and check where the mistake is because I didn't get full marks in it. So you can't use your calculator to get the answer, but you can use it to assist you to make sure you got the right answer. No, there it is. Shift.
Is it computer? Because I type everything in.
Yes, that would be okay. Yes. Here? Yes. Yes. You could, yeah, that's fine. You know, the teacher doesn't like using the calculator. He tries to avoid it as much as possible, okay? So yes, you can do it there and that'd be fine. Okay. Okay? Yes. Right, so let's just have a look here. Yeah, that's the same as that one. So just a point now at the end. Yes. Ah, Shaban. Hurry up. Did you write this down? Let's sit quietly. Okay, so next we're going to look at, is it always possible or always allowed to put in two numbers? And it might seem like the answer is yes, because as long as you can put in the x at the end, why does it matter? So for example, I think I gave you a log x one a moment ago. Where's it gone? There, this one here. The 1 over x1. Yeah. So I'll just go back to this for a second. So let's just imagine for the moment I change these numbers. So if I was to change these numbers here and here, well then these would change, these would change, and these would change. So all that would really change here would be the numbers at the end. Yeah? So for example, what about if I put in here -2 and -9? My answer at the back would be log -9 over -2, which is the same. So it might seem like I should be able to do that, but I can't always. So I'll show you an example of why you can't, or make it more clear. So let's take, for example, this one here now. 1 over x squared. Oh, and if I go back to my log one, where's it gone? Yeah. I definitely couldn't put this as 0, because what would happen at the end? I'd get 0 here. So that's clearly wrong. But let's have a look at this one here. So again, where's it gone? Lost. There it is. Okay. So let's say I do something like this one here. -1 to 1. So can I use 1 here? Yeah, no problem. Can I use -1 here? Again, no problem. So first I write it like this, with a -2 as the power, and then increase the power by 1, divide by the new power. Or if you want to write that a bit neater, it'd be -1 over x. Okay. So first I put in 1, and then minus, and I put in -1. So if I put in 1, what do I get? Well, that'll just be -1. And if I put in -1, what do I get? Can you see? Yeah, I'll get 1. So -1 minus 1? No. -1 minus 1? -2. Now you might say, what's the problem here? I used 1 and I used -1, and that's fine here. I used 1 and -1, and that's fine here, and my answer is fine. But actually, it turns out that this is not right. This is wrong. And I wonder if anybody can see how we can know if we're using the right values or if we're using values that'll give us the wrong answer. Any ideas? So let me tell you the way you get to think about it. When I put in these numbers here, we need to think of x as being belonging to -1 to 1. So we need to think about it as like this. Okay, so that's the first thing. If x is from -1 to 1, and let's just imagine x moves from -1 to 1, will it hit any problems?
0.
Oh yeah, it'll hit 0. So we say that this interval is no good. So I know I called them lower limits and upper limits, but it's better if you think of them as intervals, as going from -1 to -1, and it travels all the way in between. So as it travels there, it can't hit any problems. So for example, if I replace x squared with square root x, would there be any problems or would it be okay? But square root x will have 2 problems now. What would be the 2 problems?
Square root minus.
Well, you'll have square root of minus numbers when you start at -1, and then it still has the problem of hitting 0 when you have 1 over square root x. Okay? So, in some situations, like if you were to look at 3a, we have two pieces of vocabulary. We can say that it's proper and we can say that it's improper. We only look at proper ones, but I would like you to spot which are the proper and which are the improper. So the first one, is it proper or improper? In other words, is it valid or invalid? No. It's invalid because it will include negative numbers in a root. Then what about the next one? Well, let's see. The problem is when minus 9x minus 2 equals 0. So that means x would have to equal 2 over 9. And 2 over 9 is not included. Oh, no, it is. No, it's not included in the interval minus 5 to minus 7. So in fact, it'll be fine. What about C? Proper or improper? Proper. Because the problem would be when x is what?
6 over 5.
5 over 6. But 5 over 6 is not included in the interval 2 to 4. So it's fine. Alright, what about the next one? D.
Proper.
Proper. Because the problem is when x is 0, which is definitely not included in 4 to 12. Okay, now what about F? Proper. You see, the great thing about sine x is that you can put any number in it. There's no problems. So what about the one with the E in it, in I, 3I?
No.
Proper or improper? Sorry, is it I? Yeah, the bottom there, 3I. Proper. So you can only make improper ones when usually two things happen. When you have a denominator, and you don't want this denominator to be 0, or well, there's another one as well. There could be square root. You don't want square root of negative numbers. And what else? What other things are not allowed to be used? What other functions have problems?
Roots.
Roots, yeah. And what else? Something else? Some other function we've done that does not allow for negative values or 0. No. Log x. Yeah, log x, natural log. Fractions? Fractions are cool. No problem with fractions. Yes. If the denominator could be 0, basically, is a problem. So anytime that the denominator could be 0, or you're not allowed to use negative values, you might have something that's improper. You'll never be asked in the exam to calculate an improper one, and you'll never be asked to fix it. I just want you to be able to know that sometimes the numbers are not allowed to be used. So just because you have numbers there doesn't mean you can use any numbers. That there's certain numbers not allowed. And you're not allowed to break what's inside it. Okay? So this one here breaks when x is 0. And 0 is part of the lower to the upper. So you're not allowed to actually calculate this. And we'll see more the reason why in the next class. Because in the next class, we know that this represents area. And what happens on the graph when x goes to 0? What happens to this? Not disappear. What happens when you divide by 0 on a graph? Any ideas? Yeah, the graph shoots up. So if you're using this to calculate area, you can't calculate something that's infinite height. But anyways, that's more for the next class. So the last example there is just so you can appreciate that not all pairs of numbers are allowed. But in the exam, they will be. They'll always give you ones that work.
And this one is not working, as you said.
Yes, good point actually. I never thought about that. If you tried to type that in a calculator, it should give you back an error. So that's another way you can check. Yeah. Okay, yes. Oh, there is no answer here. The answer, you can just, this is just me trying to explain it to you. The answer here is just the word improper. That's it. Now which ones to do? Okay, the first 5 in each.
last
For real,
one.
man?
Just 5.
The last one.
Please.
But they're really short. Like I think I've actually given you the 5 answers already.
Yeah.
Yeah. So no complaints.
Every day.
That's right, Amber. Every day daily homework. You're right.